as this air goes through the wheel, and as the latent heat in the air is removed, there is a transfer of energy from latent to sensible called the latent heat of adsorption that adds sensible temperature to the leaving air. All right. Does that seem like a waste to you? Does that seem energy inefficient that I'm heating the air up? It does, doesn't it? But do you realize that the same thing happens in a traditional refrigerant-based system? When you convert latent energy in the air and you remove it from the air and it condenses on a coil surface, there's something called the latent heat of condensation that occurs. It's a transfer of latent to sensible energy at 1,060 BTUs per pound. And instantaneously, the air is heated up. But because the coil surface is cold, it immediately removes that heat. You never see it. You never know it's there. You never think about it. But it is. It's the latent heat of adsorption. It's a part of the psychrometric process. In my device, it's the same thing. It's the latent heat of condensation. We just call it the latent heat of adsorption. And I simply have not removed it from the air yet. I could put a cooling coil, a sensible only cooling coil, downstream of this to bring that temperature back down to whatever I needed it to be from a discharge process. But if I can use that heat to my benefit, would we not consider that heat recovery? Yes, we can. And because I'm heating this air up, when I mix it back in with a colder airstream, the combination of the two will usually raise the mixed air temperature a few degrees above what it's coming back at. And then all I have to do is sensibly cool it down a few degrees from there to achieve the conditions I want in the space, instead of having to drastically overcool the air with traditional refrigeration systems and then drastically reheat it back up with typically natural gas, which is typically fossil fuel based, which is typically a huge carbon emission source. I get away from all that. I can eliminate all the reheat in healthcare systems using desiccant dehumidification, and it is a tremendous energy boon for hospitals. Would you not agree?